Yeah, so Frederic and I are going to be presenting today. We're calling it just a prototype of private pipeline for automated recognition of personal information and record aggregations, which is more of sort of a work in progress descriptive name at this point, but sort of that's our punchline there. Presenters, so myself, Nicholas Rivard, I'm a Master's of Computer Science student at Carleton University, and I'll be presenting today with Frédéric Simard. He's a postdoc also at Carleton University, and we're both working with Michel Barbeau, who many of you know and presented earlier. So first for context. Um, everything that we're going to be discussing in this presentation pertains to the MAO5 work stream. So that's headed up by Jim Suderman with his team, and it's often referred to as the content PI study. So basically, you can imagine an organization responding to requests for information and privacy law requiring that, for example, personal information be protected. So you can't just like you're obligated to release the documents, but you can't release anything that contains information about people's medical records or things like that. This process, I'm sure as many people can appreciate, would be very labor intensive, and so we're trying to basically partially automate it. The proposed methodology that Frederic and I are going to present uses something called graph retrieval augmented generation, or GraphReg for short. We'll explain a bit more about what that is shortly, but basically GraphReg augments a large language model chatbot by giving it access to a knowledge graph. So it sort of constrains its answers to information that is in the knowledge graph rather than, drawing inferences from some of the training data on Reddit or like whatever worst case. In this case, you're constraining it to being able to only provide facts and responses according to some curated knowledge set that you've given it or data set that you've given it. I'm just going to adjust the size because it seems like it's a bit. Is that better? Or is that too small? I'll just go with it for now. Let me
That's
know
what
if
I
it's too
was
small.
noticing. It was stretched, but that looks good.
That's it. Okay, perfect. Thank you. So first, just the proposed solution. We'll kind of get more into the weeds in the subsequent slides, but I just wanted to give you a few screenshots to make it a little bit more concrete what I'm talking about. So the first, the large picture, sort of in the top, that's an interface to basically like there's an online cloud service that we have two versions of it, but one of them uses that. And you can see like on the left, there's a menu. You can drag and drop or upload different kinds of documents, media, or whatever. Those will then get parsed into basically nodes and relationships that then get put into a knowledge graph. You can see the sort of main big table there that's showing off some of the different documents, their status, whether they were uploaded or not, the file type. If I was to, this is just a picture, but if it was the real screen and I scrolled to the left, to the right rather, you could see how many nodes and relationships put into the knowledge graph and all that. You can see in this particular case, it's using GPT-4. You can generate the knowledge graph, you can preview it and visualize it. And here's an example of a visualization of, this is just a subset of the knowledge graph, but this is just like for one of the emails. I'll explain more what this is in the subsequent slide. And this is just a preview. It's pretty small here, but again, I have a slide where I actually get into this, but you can see me asking it a question and it giving me an answer. So it's just like any other chatbot kind of service. So just for a quick overview, we're sort of conceptually breaking this presentation up into two major phases, preparation and usage. Preparation pertains to setting up the system, configuring it, all that, everything that goes into getting it ready for usage. And then usage is just when an actual user is making use of it as a service to help them out with their work. And so in preparation, we're going to talk about data collection, defining the knowledge graph schema, having the LLM extract typed nodes and relationships from collected data and populate the knowledge graph with the collected data according to the schema. And then for usage, we're going to discuss querying the LLM, so that's prompting it or asking it questions, and then the retrieval augmented generation process to help it give curated and considered answers. So just real quick on data collection, there's lots of options here, but I'm just trying to highlight with this slide on the left side, that panel. Again, that's where you can upload your data, and you see right away, by default, there's many different options. We're, in our case, just looking at documents. You could do images, you could do videos, all sorts of things, upload websites, all the rest. We haven't tested all of that, but the functionality apparently is there and it's supported. We've just been looking at documents so far. And then this is just a screenshot on the right, just from a directory in my computer where I'm storing some of the files that Jim gave me. And so the first 5, the doc 1 to 5, those are just examples of emails. Those are from the Hillary Clinton email server leak from 2016, because they contain examples of information that at the time wouldn't have been publicly available. It just so happens that it is now, so we can use it and we can present and that kind of thing. But so we're using that just for testing purposes. Below that, you have the Privacy Act, or a Privacy Act anyway. And then below that, we have a telephone directory. So that's, I think it was from 2011. It's a State Department telephone directory. And so we'll get into why this is all being put into the context that's used to populate the knowledge graph that the LLM will use. So next we'll talk about schema, and I'll pass the torch over to Frédéric.
Thank you. So hi everyone. So in order to build a knowledge graph, you essentially need what we call a graph schema, but the graph schema itself contains more ingredients. So essentially what you want to do is you want to tell an LLM what the LLM itself should be looking for in order to build a knowledge graph. So what it's looking for is a set of node labels or entities that will represent concepts, and also so these you have to specify, and you also want to specify a set of relationships between those entities. You could leave them out. You don't actually have to specify them, but if you don't, you're basically hoping the LLM will find the answer you're looking for, which might be more difficult. You also want it's also good to provide a prompt template. So for those who are familiar with let's say ChatGPT, for example, who have played around with LLMs, a prompt template is kind of just a more complicated version of a prompt. So instead of just telling the machine, I want you to do this, well, you're telling it, I want you to do this, but also here's the context in which you're performing this task. Here's how you should return the output, what kind of format. And so this graph schema, so the prompt template and the set of nodes and relationships are all used to build a knowledge graph. So to tell one LLM how to build a knowledge graph, but you can also provide a prompt template to perform the graph RAG, so the retrieval augmented generation, because this can also use another LLM. So you might want to tell this other LLM, okay, I want you to retrieve information in the knowledge graph, but I want you to perform the retrieval in this specific way, and these are all it's a prompt that you send in a natural language. Next slide, please. And so I'm not going to detail the prompt template for the graph RAG part because it's very similar to the one for the knowledge graph builder. But here you can see an example of a prompt template that is used to tell the LLM how to build a knowledge graph. So the first line is essentially you see sort of the general context, what is the LLM, what is the LLM doing? Like the LLM is reading PDFs. It needs to summarize information contained in them. Now, next you see the task itself. So you're telling the LLM, you need to extract the entities or nodes or node labels and specify the types. You need to extract relationships between those nodes. Then you can tell what format the answer should be, in what format should the answer be returned. So specifically, it's a JSON type of format, which is a bit technical, but it's essentially, it's a dictionary. And this is important because the software that will build the knowledge graph, this is what it will take. It will parse all these dictionaries and form nodes and edges in the knowledge graph. And so you can actually and as much if you add more and more information in that prompt template, you can kind of guide the LLM, and so that it creates a knowledge graph that is more fitting for your purpose. Next slide, please. So next you can see here an example of entities or node labels, so that the LLM should be looking for. Here I just wrote like very generic, like sort of like general ideas such as like facts or opinion, because these might be expressed in like these were for the Hillary Clinton examples that Nick talked about. So for example, you could look for a role. You could also like tell actually in the prompt template, you could tell the LLM like use those, start from those entities, but if you find it relevant, you can add entities yourself. In the prompt template that I just showed, it actually says the opposite. It says, please do not add information that is not found in the node label. So you can play around with this. So you can also see on the right examples of relationships or the link labels, which are usually the entities will be nouns, the relationships will be verbs. So you have relationships between the nouns. So, and these are very designed for the text we wanted to analyze. So for example, like sends message to or has opponents. It's really because it was fitting to analyze these Hillary Clinton emails. Next slide, please.
All right, so going back to other steps in the preparation phase. So we have LLM makes node and relationship extraction. I won't go into all the details, but there's plenty of documentation available, but I just wanted for this slide to show an example. So this is the knowledge graph, or the portion of the knowledge graph pertaining to one of those email samples that Jim provided us, test document number 1. And so I assume you guys can see my mouse. So I'm pointing at the blue circle right now. So that represents in the knowledge graph the actual document itself, the PDF. But you can see here, there's these 2 green circles that it connects to, and they have the actual title of the document on it. So what's going on there? So the reason why this is done is because the LLM can only take in inputs of a certain size at a given time. And so the process basically, when it's making the knowledge graph, it splits up basically the information pertaining to this document into different, what it calls chunks. And so these are bite-sized. The LLM can ingest one and then ingest the other. So it's just sort of like an implementation detail. So you don't need to worry about it too much, but just wanted to highlight that there's some things going on there that might not be evident what they are initially. And then all the, I guess, salmon circles are basically entities in this case. And so we have, here again, it's the Hillary Clinton email leaks. And so we have, Jacob Sullivan, and he's got his email here. What else we have? We have Mexico City, Canadian ambassador or something like that, presidency. Is Gavin Sick was identified, foreign ministry. So just specific entities, named entities, etc., that feature in the document. And then the relationships that Frédéric was talking about a moment ago, you can see there's examples here. So this document has this entity, that person there, or that email there, this person there. So that's an example of one of the documents. Moving out, this is the knowledge graph as it currently is. And so that document we're just looking at is right here. It's just kind of arranged a bit differently, but you can see the one document, the 2 chunks, and then all the entities. And interestingly, at this stage, where this is just, this isn't inference so much for the question answering part of it, but this is just representing the data as such, as it is. So that particular email doesn't contain entities that are mentioned in the other emails or in the directory or any of that. And so it kind of winds up being unconnected at this point, versus the other emails, that's sort of this blob of nodes over here, and they're more tightly connected. Then here we have the employee directory, which has lots of connections because it names individuals that feature in these emails. So there's connections there. But you can see also it's a very big blob of nodes, right? Like it's a whole phone directory with lots of people in it. Over here we have the Privacy Act, and so it's pretty big too. But you see how, again, no connections. So it mentions things like types or categories of people or entities, but it doesn't name individual entities. So for example, I think I mentioned Jacob Sullivan on a previous slide. So he's not mentioned by name in the Privacy Act, right? But the concept of a government employee is, for example. So at this stage, it's unconnected. We'll see later that the system manages to sort of connect the dots and answer questions using all of this. And then here, I just want to highlight this. So when I'm chatting with this thing, each of these green dots represents me starting a conversation stream with it. And a conversation is defined simply as I ask it a question and it gives me a response. And that's the whole conversation. And then I ask it a question, it gives me a response, that's another conversation. So you can see in this, at this particular snapshot in time, I had asked it 4 questions and it had provided me responses to those. And so 2 of those conversations I've listed here, where we're moving on to the usage phase. And so we're querying the LLM chatbot. And so I just wanted to highlight these 2. I think that they're illustrative of some of the potential of it. I should say, full disclosure, it's not always reliable. Sometimes it gives funny answers or forgets things. Like it's not perfect. There's still work to do on it. But the results so far have at least been promising. So as sort of an initial proof of concept, we think it's worth looking at. So in the first one, I asked, what personal information do you have about Hillary Clinton? And again, bearing in mind what Frédéric was talking about earlier with the prompt template, that was basically enforcing that the LLM is limited to providing information from the knowledge graph. So bear that in mind when you're reading these next ones. So I asked, personal information do you have about Hillary Clinton? It says the provided context, that's the knowledge graph, does not include personal information about Hillary Clinton, such as her private life or personal details. Again, I didn't teach it what personal information is or what private life or personal details are as concepts. It's inferring this using the documents. Then it goes on to say it only mentions her professional roles, such as being the Secretary of State, blah, blah, blah. And so the reason why I want to give this example is because it reached into the Privacy Act, found relevant concepts, mapped those over and made the inference. So it's drawing the conclusion that, well, there are details about this person, but they don't qualify as personal information according to the Privacy Act. And then it sort of gives examples and counterexamples. So I thought that was neat. It manages to make that with a fairly rudimentary setup, it manages to make that connection. Another question I asked, who from the State Department does Hillary Clinton communicate with? And so in this case, I just wanted to make sure that it was using the telephone directory, the State Department telephone directory. And it did. It gives me an answer. It lists them out by names. It gives their job titles. Sometimes it adds a little flourish, like is a frequent collaborator. These kinds of little things that it does. But yeah, it had no problem doing that. And again, none of this. It wasn't trained to do this, right? It's just like a normal chatbot, normal LLM. But in combination with the knowledge graph that it's querying, it's able to make these sort of runtime inferences that aren't actually part of its training purpose. Okay, over to you, Frédéric.
Yeah. So we first talked about what is the knowledge graph and how do you build it, and now in order to basically explain what is the RAG, I think the following diagram basically summarize it properly. So the retrieval augmented generation, the general idea is you have a question, and so you assume there's a knowledge graph that was already built somehow. Like you assume that it's built properly. So you ask your question to you send it to a tool. This tool will convert the question in a way that the knowledge graph can parse it, and will do a form of similarity search. I'll talk a bit more later about those types of search. But essentially, so like there's a search, it will search in the knowledge graph, what are the nodes, what are the information that are relevant to this query, to this question, then send the relevant information back. And with this relevant information and that question, both of those together are sent to an LLM, which will itself generate an answer based on all that. Because and the strength of LLMs here is that they're really good at forming proper sentences, like forming so especially in English. So the second LLM we use is essentially will just wrap around all the information into a proper sentences and proper paragraphs. And so you can notice here that there is a second LLM. So there's a first, when we build a knowledge graph, we use an LLM. We send it a prompt template, like a set of nodes and entities to look for. And so this first LLM built a knowledge graph, and now we're using a second LLM to do the graph RAG. And I'll detail how we can use both of them. We can parameterize. Next slide, please. And so to sort of go back to basically the title of our presentation was something to do with prototype of private pipeline. Well, this diagram here basically summarizes what that pipeline is. So Nick described how to perform, like how to build a knowledge graph and how to perform GraphRag with tools that are already available. You can find them online. It uses OpenAI, but unfortunately, those tools, even though they're very efficient, they perform very well. Well, they're online, so and they rely on they work on the cloud, so there's a risk of there's a privacy risk. You don't necessarily, if you have sensitive information, you don't necessarily want to send it over the internet. So what we've been working on is to basically do the same thing, but that works on a local machine. Most of it actually works, and most of it runs on a local machine, except this first step here, which is setting up the Neo4j connection. So the Neo4, so in that step, we simply we use Neo4j to host our graph database, to host our knowledge graph, because and this is mostly just a convenience thing. It simplifies our work, but it's not required. We could actually remove that dependency. We could put everything back in our local machine, and then everything would be private. And so generally, the program works as follows. So first, we set up this connection to Neo4j so that which will host our knowledge graph. Then we load parameters, which are and I'll detail them a bit more in a minute. And now you can see that we're setting up two LLMs. So one is to build a knowledge graph. If you wanted to build a knowledge graph, one is to set up the GraphRag. We also have the choice of setting up an embedding model. And again, for those who are familiar with LLMs, like embedding models are sort of like these essentially vector spaces that where each vector corresponds to a word. But without going into too much details, embedding models can also influence the accuracy of the result. If we want, so if required, we rebuild the knowledge graph. It's not necessary. This is actually can be useful because you might want to use, for example, a very big LLM, like a very the biggest you can run on your computer, that will give like very accurate results, and you might want to use that just to build a knowledge graph. And then when you want to query, when you do the GraphRag, you might want to use a smaller LLM that can be very quick, that will run more quickly on your computer, and then not have to rebuild the knowledge graph. You just use it to query the knowledge graph that you already built. So finally, and then after that, we set up the vector and cipher retriever. Cipher is the tool for to actually query the structure, to perform retrieval on the structure of the knowledge graph. I'll go through it in a minute. And then we ask a question and retrieve the answer. Next slide, please. So this thing about parameters is actually is one of the points that makes our program very modular. So we're basically using what's called Olama, which is this website that hosts a bunch of open source LLMs and embedding models. And so we have at our disposal a bunch of LLMs. So we're not relying on just, let's say, OpenAI. We can use, for example, here I've been experimenting with Llama 3.2 and with 3 billion parameters, which is very small. It's sufficient. It runs on my computer, for example. But we can try with other ones. I tried with DeepSeek. There's Mistral, which is also performs well. There's different and there's different LLMs that from different companies, but there's also like different, even the same company will have some that are different sizes. So you can have like a small one that will return answers very quickly, but you can have like a bigger one if you have access to a server. You can run it on that server, for example, if you want a very accurate knowledge graph. So sorry. Yeah, so you can keep going. So yeah, so like this part is very modular. There's a lot of parameters that we can play around, which makes it very so that we can make it more tailored to our needs. And so the main function here goes as follows. So first, as I said, like we set up our connection to Neo4j, we load the parameters. Then we use, as you can see, we're using Olama, which again is this thing that gives us access to all these LLM models, so that we can pick the one that might seem more accurate for our purpose. Next slide, please. Now, if we want, we can rebuild the knowledge graph, which but we don't have to do that every time. Next slide, please. Yeah. And then finally, so we'll query do the graph rag. So we'll query the knowledge graph. This requires defining what is called retrievers. Again, there's multiple types of retrievers. So like I've been mostly using the ones that are already defined by Neo4j. The two main ones are like a vector retriever and a vector and cipher retriever. So vector retriever is simply does a form of, well, it's a vector search. So you can think of it as a sort of like a semantic search in the space of embeddings of the nodes in the knowledge graph. But using cipher is also interesting because cipher is this tool that Neo4j has that uses a structure of the graph, and this is where templates can come into play. So you can use a prompt template for this retrieval part to actually tell the LLM when you're going to do cipher retriever. So when you're going to use the context of each node on the graph, I want you to go, let's say 3 hops away. So you go the neighbors, and then the neighbors of the neighbors, and the neighbors of the neighbors of the neighbors of each node. I don't want you to go further than that, because that might be too long, but I want you to go at least this distance, because then you're going to get a very good and relevant context for each node. And so you can perform these, you can mix and match, like use different retrievers, and then you can eventually like even maybe wrap all of that into another LLM that will like take all the answers and find out which is more relevant. So in conclusion, so we try to describe what is a knowledge graph, what is a graph rag, and how these how basically you can build your knowledge graph so that when you want to use LLMs to answer questions, you can constrain it to the proper context. We showed how this can already be used with tools that already exist, but also like how we have a program that works mostly locally. Again, it's a small dependency that we still have that makes it non-local, but most of the rest is local, which means that it is private. There's no information leakage. Another interesting thing about working this way is that it makes the program understandable. So there's no black box, there's no mysterious thing happening. The only mystery is the LLM itself, but we generally understand what LLMs do. So if we understand what the LLMs do, then we can understand the rest of the program. So which makes the results more trustworthy. And finally, it's all modular and customizable, so we can better tailor them to our needs. Thank you. That's all I had to say.